So today I'm going to talk a little bit about Node.js and JavaScript in general on both our Visual Studio development platform and then also on Microsoft Azure, our cloud platform. And the first question: how many people here have experience with Node? Or so one of you. Okay, great. That's pretty common. It's a fairly new thing. And so the first question that you ask yourself is why would I do this? Why would I switch off of Java or using C# or any of these other platforms that you've been using? And kind of the first and the biggest reason that people do this is so that they might already have a team working on their front-end app, their front-end web app in JavaScript, right? So you're building the web front end. And using Node allows you to use those same people, kind of move them back and forth very agilely between the front end and the back end. I think this was the original motivation. So Ryan Dahl was the guy who started Node. I think one of his original motivations were to be able to have that agility within the team, be able to move people back and forth between front end and back end as the project's needs came up. Another thing that Node, one of the trademarks of Node, is that it's asynchronous based. Or another way of saying that is, and more importantly, the most important mental model to have about Node is that it's single-threaded. So in contrast to a lot of the web platforms that we use today, ASP.NET or servlets or whatever, where they're multi-threaded, Node runs in a single process, or it doesn't run in a single process usually too, but also a single thread. And so that, in some ways, it makes it easier to reason about, right? You don't have there's not the possibility of these multiple threads causing trouble with any shared data in the system. But it implies also that you have an asynchronous model, right? You can't block, because that would, in a single-threaded system, would block the entire web server. And so what instead you do is you have callbacks. So you provide a function. So Java is a very functions are first class in JavaScript. I wouldn't go as far as to call it a functional language, but and so a lot of the methods within Node actually take a function that gets called back when that operation is finished. And in this way, you can prevent any operation from blocking the server. What happens is it does something like I/O that would it does block to perform that operation. But in Node, what it does is it switches to the next thing that needs a callback that has become ready. And so it's really good for things like, it can do that as opposed to threading. It can do that very, very efficiently. And so it's very good at things where it require a lot of concurrency. In particular, if you're doing streaming of anything, be it video, whatever, Node is devastatingly effective at that because of that model. It basically just switches back and forth between all these different these ports receiving, or you're sending data out on. And streams the data to them. And it can do that in a very lightweight model between those different streams. So it's very good at that use case I/O. A use case that it's very poor at for the single-threaded reason is anything that has to do with lots of computation. And so if you think about, pretend, here in Chicago, finance is a big thing, right? If you're doing a lot of financial calculations in your application server, Node is maybe not a good choice. Floating point numbers in general in JavaScript leave something to be desired, so it's probably not a good choice anyway. But doing anything where you're cranking through a lot of computation, because that doesn't block, it actually won't jump on to another request. And so the entire time you're doing this long computation, you've essentially blocked the web server. So that's an example of something that's not good at. But if you buy into those, or you have a use case where those things are useful, you get all these bottom things. For free. And these bottom things are a reason a lot of other people choose it. And probably the best is that it has a very vibrant community around it. I'll show that in another slide, but there's an incredible community. It's because JavaScript is so well known across the developer base. An incredible community has sprung up around all the packages you basically would need to interact with third-party systems or implement something in your application. It's also cross-platform, and a lot of that's driven by the fact that it's open source. So it was initially it was part of it was built by Joyent, who's another cloud provider. But they had the foresight to open source it. We've added, Microsoft has invested in the platform. We actually use it internally. And so we ported it to Windows, initially for a project that we're doing at Skype. But the positive part of that is that we released that for the whole community to have. As we were chatting earlier, there's a project called IIS Node. You don't have to use IIS, but the thing that makes it possible on Windows is this container called IIS Node that allows you to run Node on Windows as well. And so you can use it on whatever server platform you're using, and that's fairly abstracted away from you. So you don't have to know much. There's not much difference in terms of the application model, depending if you run on Windows or on Linux or on Sun OS or whatever. And probably I mentioned this before, but obviously JavaScript is up there, and I would call it one of the big four, right? So Java, JavaScript, well, maybe 5 or 6. C#, C++, Python. These languages that just have a tremendous amount of traction. So this is, I think it's a graph of number of things committed to GitHub, and then the number of packages that they have available in the ecosystem. And so JavaScript has really shot up this chart, and that's mostly because its ecosystem is growing really quickly. So the red line there is the JavaScript ecosystem. These are the number of packages that are available in the ecosystem. The two bluish lines there are Java and Ruby as the kind of the leading platforms of right now. And there's a number of other ones there, but nothing has kind of the growth rate of Node. And that's led, come on. Why isn't it going next slide? You can do it. Oh, it did it, of course. The second I hit Escape. Maybe that's what I needed. All right, so that's led a number of fairly high-profile companies to take on Node, right? So probably the biggest ones here, Skype uses it. Anytime you make a call in your browser, it's actually using Node to do that streaming between your browser, the Skype infrastructure, and then relaying it out to the rest of the callers. Yahoo uses it pretty extensively inside of their operations, as does PayPal and eBay, which are the same company. And then we use it. If you've ever used, has anybody used mobile services on Azure? Well, if you had, mobile services uses this for the kind of the scripting model behind it. So mobile services is sort of like a parser or whatever for making it easy to build a mobile web app. And so we use Node.js extensively behind the scenes to do this. And because of that, as I mentioned before, it's really a first-class citizen of Windows Azure or Microsoft Azure, our cloud platform. We have a Node module, allows you to work against the cloud. And Node has, I would say, across cloud providers has very good, client support for being able to use your application against different clouds. Our client library is open sourced on GitHub. It's developed actually very actively with the community. And in fact, our command line tool, if you don't use the PowerShell version, there's a Node command line tool that we actually use for all the other platforms. So for Mac and for Linux and for anywhere else you want to use, work with Azure, we actually use Node to provide to run the command line tooling. Again, because it has such a rich cross-platform support. And so, the natural progression of this is we're using a lot of Node inside Microsoft. Our developers are obviously using a lot of Node. And so we've decided to add it to Visual Studio. And what we're doing is we're taking a slightly different approach with Node, building on the fact that Node is an open source project. We actually, obviously we took Node straight from the open source project, added Visual Studio, and then we've added on a plugin on top of Visual Studio that's actually been cooperatively developed with the community. So we've put a number, 5 to 6 developers inside Microsoft on Node.js tools for Visual Studio. We've had a number of really good community contributions as well. Why is it suddenly not behaving? All right, here we go. Yeah, and so you don't have to have a license or one of the premium editions of Node or of Visual Studio to run these tools. We have a free installable version of Visual Studio called Express Web. And that includes everything. You don't lose a bunch of functionality because of that. So we have it has Typescript support, which I'll talk about in a little bit, and then also has local and remote debugging of your Node.js apps. And then, as I mentioned, since it's an open source project, we actually had two things that are actually contributed. So the edit and continue, the ability to change your code and still continue debugging without having to restart, was actually from a contribution from a community member, Dimitri. And then also NPM, which is the Node Package Manager. That integration was actually contributed to by the community as well, and we're bundling that with it. So Visual Studio support is more or less what you'd expect. It has IntelliSense, it has syntax. How many people use Visual Studio from time to time? Okay. So basically, it's the experience that you expect. Now let's just apply to a new programming language, essentially. Has IntelliSense, debugging, profiling, the same project system, and Azure deployment that you're used to with C# projects. Same thing comes to Visual Studio. You can do this against Azure websites running in the cloud, even if they're running on Linux. It has full support for that. And you can download it today. It's currently in beta, but it's at nodejstools.codeplex.com. And there we have all the documentation, videos, et cetera, et cetera. And so that's kind of the highlight of, the overview of what Node does, where it fits in, and what kind of support we have in Visual Studio. I'm going to jump in now and do some demos for most of the rest of the presentation, across a number of things, including our Node.js stuff. Oh, and then of course it's not showing up. Hang on. Go to the control panel. Mirror displays. All right, great. Okay, so, and no, I don't want to update that. All right, so what I'm going to use as kind of an example to kind of run through this is a very simple app. I built it in kind of the new architectural paradigm of the day, which is as a single page app written in Ember.js that works against a REST backend. And so I'll walk through that in a little bit of detail, but it's a very simple Twitter-like app. I can say, oops, hello, GOTO, and adding that adds it as a message, saves it in the REST backend and whatnot. So super simple application. And so what this application is doing is an Ember app, as I mentioned, and essentially it routes, what a single page app does is it essentially routes internal to the web page. So everything after this hash you can really think of like the way you've done on a web server if you haven't encountered this before. And what it does is it works down to essentially a model of what this message looks like. And so a message in this very simple system has a timestamp and a body, which was the hello GOTO. And this Ember app works against an API backend. I have two of them here. I'm going to show it in the cloud later. But here I'm working against a Node.js app running in here locally. So I'm going to switch over and show you that. Since a lot of people haven't seen a Node.js app before, I've written this. There's a couple of kind of more complex things in here, but we'll jump over that. Essentially, I'm using a library called Express, which is the kind of the equivalent of ASP.NET MVC or whatnot in the different other ecosystems. It allows you to define a set of routes and controllers to field those requests. And I'm using that to essentially set up a very simple set of API endpoints. And so I have I can field a post request to the /messages endpoint, and then it's going to call this create controller to create a message. I can do a get on all the messages, and it'll pull down an index of all the messages. Or I can grab one at a time. And so what that looks like then is essentially what it does is it takes the message that I posted up to the web service, creates a model of it, saves it, and then sends it back in the response. So a very, very simple REST API backend. I'm using, for this particular example, I'm using the Mongoose ORM, and what Mongoose allows you to do is it allows you to use MongoDB in your application. And so here again is the timestamps and body. I assign a default. If you don't send up a date, I'll assign the current date to it, and then this saves it as with a type of string. So very simple system. We can, so as expected with, we mentioned before, if you want to go, if you actually want a single step through this, I can actually set a breakpoint, and then if I go back to that web application, oops, oh yeah, there it is. And so it's broke into the debugger here, and so as you'd expect, as I single step through this, I now have a message that that has this hello again body into it. I can then save the message. I can see that there was no errors saving the message, and so on. And so as if I was debugging this application, I could go through and single step exactly the same way if in the other languages you have in Visual Studio. And so that's pretty interesting. I think it's interesting in the fact that it's more or less exactly what you expect, and there's really not a lot different to it. The one addition that we have, as I mentioned before, is you have the ability in Node you can define dependencies, and so if you've used NuGet in the .NET ecosystem or Maven in Java, you have the ability to define dependencies and pull those in. And so here I'm pulling in the Express framework from the Node ecosystem. And so within Visual Studio, you can actually automatically fetch all of those dependencies without having to drop to the command line. What else? All right, so we have this application, and now we want to be able to debug. We want to be able to send it to the. We essentially want to deploy it into the cloud. And so one of the great things about Windows Azure, it actually has a platform as a service layer called websites. And so what this allows you to do is essentially use a Git repo as a destination for deploying your applications. And so I'm going to create really quickly here a, oops, I didn't want to do that. I'm going to do quick create. I'm going to deploy a backend for this called messages-be on Azure websites. And I'm just going to create this website, and this will take a few seconds to initialize. But essentially, this is building a container for me that I then can push things to, like this back end, to essentially deploy my application. And so it spun that up. So now I have a fully exposed on the internet endpoint for this application, and I can then set up how I want to push that code to the website. So there's a number of options here. You can use Visual Studio Online. You can use a local Git repo. You could have it such that every time you committed to GitHub or to, I think Bitbucket's down here somewhere, yeah, or Codeplex, it automatically will watch those and using a webhook deploy that code onto your website. And so it's great for kind of continuous integration scenarios where you automatically want to deploy it, maybe run some tests against it, whatnot. I'm just going to use a local Git repository for this. And so it's going to spin up this container and then give me a URL that I can use with my source control. How many people have used Git or use it day to day? Okay, friend number. Okay. So this is just a Git repo. I'm going to copy that. I'm going to go into not that one, but the other one. And I'm going to actually I forgot to remove my old one, so I'm going to add a new one back in. And basically, I'm just adding a remote repo address for this local repo called with the URL that it gave me. And then what I can do is this messages directory is the app that we were looking at, that Node.js app. I can just do git push Azure master, and it's going to take the current state after I enter my password, of course. And it's going to take the current state of that repo and push it up onto Windows Azure. And so what it does is it pushes it up there, but then it also starts the commit or it does the npm install that you essentially do with every Node.js app. And this is fetching all the, within Azure, it's fetching all the dependencies for this application, including Express and the other dependencies that we define in our package.json. So it's pulling all that down, and once the deployment is complete, it'll tell us here, obviously, in this, but it also tells us here in the web console that we were using to manage the website. So once that's complete, it'll tell you it's done. Lots of stuff to download. While that's going, oh, it's almost done, I think. Well, while it's doing that, I also mentioned that we were using Mongodb for our application. One of the things that Azure has is actually a store called the Azure Store. And what I'm going to do here is I'm actually going to deploy a Labs MongoDB instance. So Labs provides hosted MongoDB instances in the cloud. So I'm going to go do that. They have a great sandbox version that allows you to have half a gig of information. I'm going to call that messages Mongo. And sure, I'll deploy it in the West. Wait for this to finish. All right, great. And so that's spinning up a MongoDB instance that we can then use with the application. I'm going to check. So it finished successfully. If I went to the website itself, whoops, I should see that this deployment is finished successfully and it's active. And one of the features is as you push these different versions of your website, you can actually roll back to the previous versions if something goes wrong. So you're not, if you have a rollback, the ability to roll back right in the website if you need to. Great. So let's go back, and I need to grab that. I'm going to grab the connection string for this. And then if I go back to the website, I can configure this so that it can connect against it. So configure. Well, it's not usually so cramped. It's quite a low resolution, but I think you can understand what's going on. All right. And so I'm just going to enter this as I have a MongoDB connection string. Instead of baking that directly into my application, I can pass it in as an app setting, and then I can apply that so it'll restart the application and provide that as an environmental variable to the application. So my application knows to look for that environmental variable and uses that to connect to the right MongoDB instance. And so if we go if we go round trip and look at the application that we were looking at right at the beginning, I'm going to change it to use as backend now. Instead of using the local one, I'm going to use the messages BE. And if we go back to the application, there's no applications because we haven't entered any yet. But if we go, hello Azure, we've essentially have spun up this locally running application working against the backend that we spun up in Azure. And so, I think the message you get there is it's exceptionally easy now to actually deploy these applications and actually essentially spin up a production level quality applications very quickly. And so let's say this application became very popular. One of the things we have in Azure or in websites is the ability to scale it. And so I was only using a single instance. It wasn't very popular at the very beginning. But we have the ability to scale by CPU. And so we can say we want to be able to scale up to, we want at least 2 for availability. We want to maybe be able to scale up to 9. And what it'll do is essentially, as the CPU goes over 80% on any one of these instances, it'll spin up another and another until the target CPU is within these bounds. And when it drops down through 60, let's say it's the middle of the night, it actually scales down your application to a more cost-effective number of instances. And so it's effective from a very effective from a cost benefit as well. Great. Yes. Yeah. Yeah. So since I used, I'm going to quit out of that just so I don't end up spending a ton of money on my credit card. Since I use MongoDB, you can actually go and use Mongodb's browser. So I just click the Manage button on that subscription that I have, and then you jump over with single sign-on over to the account that you have. And here's the, so we go and look at the messages. Here's the message that I just pushed up from that application. Mongodb has a great, for people that do use, use MongoDB, they have a great offering. You can do the same thing if I had to use this. We have SQL Azure as well, which allows you to run SQL Server in the cloud. Or we also have another partner, ClearDB, which provides MySQL in the cloud. They all have, some sort of administrative, administrative backend for working against their applications. Great. So I thought I would finish by talking. So one of the knocks, obviously, on JavaScript is that the language is a lot of people describe it as the English language of the internet, and that's not to always say a very in a nice way, right? English is sort of a messy language, right? With a lot of irregular verbs. Anybody that's learned it as a second language knows that, and JavaScript's a lot like that. So one thing that we've been working on at Microsoft is a language called Typescript. Have anybody used Typescript before? Yeah, a little bit? Okay. And so what Typescript is the goal of Typescript. It's another open source project that we're working on. And the goal of Typescript is to kind of speedboat some of the standard features that are coming out in the next version of JavaScript so you can use them today. And in the process, make the experience of building things in JavaScript easier. And so Visual Studio provides great first-party support for this. So if I wanted to convert this controller to use TypeScript, all I need to do is actually just change the extension on it to .ts. And there's a little scary warning. It's really not that scary. But now this is a TypeScript file. And the first thing to know about TypeScript is that it's just JavaScript. Since a lot of people haven't used it, I'll go through a little bit about TypeScript. We have this great thing called the TypeScript Playground. And what it allows you to do is just kind of see the TypeScript's on the left and then JavaScript's on the right. And so it shows you how things convert. And so the first thing to note is that if you just type JavaScript into your TypeScript file, you get TypeScript out. I'm sorry, you get JavaScript out. But as you start using some of these features, so let's say you wanted to use classes. And so over here we've defined a class that works kind of the way you'd expect with other type languages you might use. TypeScript will automatically convert this to use the prototypical manner that JavaScript uses to define functions of functions on functions in JavaScript. And so as part of when you use Visual Studio, it does this for you transparently. When you go to run your application, it compiles transpiles the TypeScript down to JavaScript such that you can start using some of these features. So classes are something that's coming in ES6, which is the next version of JavaScript. But with TypeScript, you can use it today. It also has support for doing generics, so being able to accept arbitrary types that we're all used to from other languages, as well as doing modules, so being able to have more modular code. It converts that over to the mechanism of doing that in JavaScript. So ES5, or I believe it targets ES5 for this current version. And so that's kind of the idea. It provides inheritance as well. So the canonical animals, it turns that into JavaScript as well. And so if we wanted to, we could take advantage of that by just simply using TypeScript, and then we could use that in, for instance, I won't do it here, but we could convert this Mongoose model that we have into an actual class that we could use in our application. And the great thing about that is that if you try to use it incorrectly, let me show this. Well, actually, I think it actually shows up here. So if I want to pass, you note that the snake is defined to take a string. So one of the things that TypeScript adds is actual typed type parameters to JavaScript. If I start trying to use a number here, it'll flag that as an error. It doesn't match the call target, and that's not what I was expecting. Please fix. And so you have better tooling because of the kind of the annotations you're able to make to your JavaScript. You have better the ability to have better in the moment understanding you're using the code incorrectly. Great. So we ran through an example of using Visual Studio to debug an application as a development environment. We deployed it to the cloud. We used some third-party tools as a data backend, and we talked a little bit about TypeScript. That's all the structured content I had. But if you're interested in going into more detail about any of the different parts of this, I'd be happy to dig in more detail.